In this problem video, we're going to chain together a molecular mass and Avogadro's number. Problem solved. So, how many molecules of water are found in 10.0 grams of water? And how many atoms of hydrogen? Go ahead and pause the video and give it a try. Okay, let's set it up. So we're going to have 10.0 grams, 0.0 grams of H2O, and I'm going to do this using the fence post approach. Now, the first thing I need to do is convert from grams of water into moles of water. So I want to get rid of grams and I want to get into moles. The problem is I don't have a conversion factor for that. But I do have a conversion factor for it because I know how to find grams per mole for water. So we're going to set that up. We have H and O. Hydrogen is 1.008. Oxygen is 15.994, but yeah, 16.00 is the sig figs our textbook gives us. We're going to have 2 water molecules. We're going to have 1 oxygen. So now we're going to grab our calculator. Okay, and we're set. So it's 1.008 times 2 will give us 2.016. 2.016. And then 16 times 1 gives us 16. So we'll add the two together. So I'll do plus 16. We'll get 18.016. 18.016. And of course, let me just fill things in. I was just trying to minimize having to go back and forth for a moment. Okay, now we chop off after the shortest decimal. 18.016 is going to round to be 18.02 grams per mole. But remember, we don't want to add any rounding error until the very end of the problem. So we're going to plug this number in. I'm going to write it as 18.016. And I'm going to write down that I actually only have 4 sig figs in play. I'm just preventing a round-off error there. I have an infinite number of sig figs for the number 1 because it's exact. And I had 3 sig figs in my original value. So either way, I'm still okay because I have 3 sig figs. And I'll end up rounding down to that in a bit. Okay, so right now I'm ready to find out how many moles of water I've got. But I got to get from moles to molecules. So I need to go moles of water to molecule of water. Now, things are cross-canceling nicely. Now I need to plug in my numbers. So I have 1 mole, that's one big thing, equals lots, 6.022 times 10 to the 23rd molecules of water. So one big thing equals lots of little things. That one's written to 4 sig figs. So I've got 3 infinite, 4, 4. I'll have 3 sig figs in this final answer right here. So we grab our calculator once again. Okay, and we're ready to go. So it's going to be 10.0 divided by the 18.016 times 6.022 times 10 to the 23rd. I'm going to get a lot out of that. So I'm going to take advantage of knowing my orders of magnitude. I've got 10, I've got 20. They're going to end up being, let's see, about 0.5. I'm going to multiply by that. That'd be about 3. So I should end up having my orders of magnitude change. So I should end up having 3.34, and I forgot the other number. Let me come back over to that. 258 times 10 to the 23rd molecules. Okay, and that seems reasonable, but let me double check it. And actually, I'm going to double check it by just putting it into Excel to try out the number for myself real quick. And on the upside, real calculators don't do this to you. I hit copy over here during the pause, I'll paste it, and yeah, 3.34 times 10 to the 23rd. So it didn't mess with my orders of magnitude, and my guesstimate was working right for about how much I had. So we end up having 3.34258 times 10 to the 23rd molecules. Now, is that a correct answer? Kinda. What are the elements of a correct answer? It needs to have the correct value. It has to have the correct sig figs, correct unit, and if applicable, the correct chemical species. So I've got about half credit right now. Time for me to go to full credit. I need to trim this to 3 sig figs, so my final answer for this portion will be 3.34 times 10 to the 23rd molecules, I'm just going to abbreviate it as molec with a period right there, of H2O. Okay, now I've got a full credit waypoint answer. Next up, how many atoms of hydrogen? So it's good that we left the original version written and circle the final answer with rounding because we don't have to add any rounding error right now. I am going to get rid of my molar mass of water, and now I've got some room to work. So now I've got to convert from molecules of water into atoms of hydrogen. And how am I going to do that? Well, let's see. I'm going to have my 3.34, now let's use my notation, 258 times 10 to the 23rd. I can't write and talk at the same time, as you see. Molecules of water. Okay, so I've got molecules of water. In one molecule of water, how many atoms of hydrogen am I going to have? Well, I've got 2 atoms of hydrogen inside of each one. So I'm just going to go ahead and write down my 2 atoms of hydrogen. That's my final answer that I needed for that part. Notice my molecules of water cross-canceled, and I'm now in atoms of hydrogen. What I've actually just done here is I've actually front-loaded something in your mind. We're going to be doing something very similar to this later on when we start using reactions to create conversion factors to tell us if you use this much of something, how much of the product do you make? So we're kind of just setting the stage for that here without actually adding in all of that effort. This would be a slight challenge problem just because we haven't done that piece yet, but it's not too hard, so it's not that big of a deal. All right, so all I have to do is multiply it by 2. I'm actually going to do that the easy way. I'm just going to do it without the calculator so I don't have to worry about my decimal places sliding along. So that'll be 6.68 times 10 to the 23rd, keeping it in 3 sig figs like my original value. Remember, exact values do not affect your sig figs. So I'll be that many atoms of hydrogen. And that would be the second.